Hello and welcome to our webinar on building water safety, geared towards schools with a focus on opening back up your facilities after a long shutdown due to the governor's stay-at-home order and the COVID-19 pandemic. My name is Mike Sutton. I'm with the Indiana State Department of Health. I work with our Environmental Public Health Division, and I primarily work on environmental related issues around drinking water. Our division has been discussing building water safety and premise plumbing issues with Dr. Andrew Whelton and Dr. Caitlin Proctor from Purdue University for the last couple of years, really. And so this webinar is kind of our next step in trying to get information out to you to help you in managing your water systems. Andrew Whelton is Associate Professor of Civil, Environmental, and Ecological Engineering at Purdue University. He has 20 years of experience in water safety and infrastructure areas. And then we also have Dr. Caitlin Proctor, who is a Lillian Gilbreth postdoctoral fellow at Purdue University. And she has expertise in microbiology of drinking water. We've all been working to better understand the challenges within premise plumbing and related water quality issues, and then also to extend that even further into the health issues around those water quality issues. So thank you both, Andrew and Caitlin, for participating and contributing to today's webinar. Just going to start screen here to talk through our agenda for today. And so the agenda for today's webinar will include this brief introduction by me, and then we'll get more into the nitty-gritty with Dr. Proctor to learn about what happens when water sits still in a building. And then also with Dr. Whelton, is going to help us to get school building water systems ready and to operate them under low water use conditions. And then I will conclude the webinar with some comments to wrap it up. So schools are more used to shutting down than other buildings because you do it every year during breaks. But during this time of COVID-19, all buildings like schools, but other buildings such as businesses and event centers and restaurants have been forced to shut down. With these facilities shut down, their buildings are vacated and their water systems not in use. Some will have shut off the water supply and drained the premise plumbing prior to vacating, and others may have allowed the plumbing to sit stagnant with water in the piping, just leaving it in the piping. Either way, it is crucial to take precautions when starting up the building water system in preparation for return to normal operations. As water sits stagnant within water lines, the fixtures, the water quality may become adversely impacted by either chemical or biological contaminants that can cause significant health risks. The corrosivity of stagnant water creates a situation where metals like lead and copper may leach into the water from the surrounding piping and fixtures. Exposures to these metals are a cause of concern for ingestion that may produce negative health outcomes, such as lower IQs and slowed growth in kids, and cardiovascular issues in adults. The stagnant water also makes it a challenge to maintain water temperatures and disinfectant residual levels. And so when that happens, biofilms can begin to build within the plumbing and increase the risk of exposures to mycobacteria and even more specifically Legionella. Mycobacteria can cause infections and issues within the bowels, so your digestive system can have issues. And of course, Legionella exposure can lead to Legionnaire's disease through the inhalation of contaminated water droplets through sinks or showers or fountains. These are real health hazards caused by premise plumbing, and we have the knowledge of how to prevent these hazards to protect our students and staff at schools. So the implementation of this knowledge is the key. Dr. Proctor is going to now give us a better understanding of what really happens to that stagnant water. So Dr. Proctor, I'm going to stop sharing my screen and turn it over to you.
All right, I think I'm sharing my screen now. So today I'm going to be talking in a little more detail about what happens when water sits still in a building. In this presentation, I'm first going to give you an introduction to our group and what we do. I'll then talk a little bit more about what happens when water sits still inside pipes, and then give you a brief overview about how complex building plumbing can be. In part 2, Dr. Whelton is going to talk in a little bit more detail about how to ready school buildings' water systems and operate them under low water use conditions. Our group has been involved in plumbing safety and plumbing safety research for quite some time. We've been doing on-site education and YouTube channel videos to talk about plumbing issues. We test water quality at full-scale testing facilities, as well as plumbing testing facilities at Purdue that are more at the lab scale. We'll do on-site testing and technical support to test water to see how safe it is as well. There's a lot more information about who we are and what we do at plumbingsafety.org. This is really a resource for everything you would want to know about plumbing, including seeing plumbing in the news, our education videos, explainers trying to give you an idea of Plumbing 101, a list of all of our projects, some scientific opinions, resources and presentations, scientific reports, and external plumbing documents. We have a lot of information specific to the COVID-19 pandemic and how it affects building water systems. This includes advice for building owners, guidance on how to create a flushing plan, and guidance issued for building water safety. We have also been doing on-site testing for schools and giving them help in trying to decide what to do for their school systems. The reason we're able to do so much of this work to support people who are going through the COVID-19 pandemic is because we were awarded a U.S. National Science Foundation Rapid Award in early March. When the pandemic first started happening and stay-at-home orders were issued, we realized that plumbing stagnation would be happening on a very wide scale. We've been studying plumbing stagnation for quite some time, and we realized immediately that this could be an issue. So we have several efforts ongoing with that project, including helping transform public awareness, which is the purpose of this video and this webinar. Now, in order to understand building water systems, we first have to get a wider view of where this water is coming from before it gets into the building. So water typically will come from the water utility, which has a water main under the street. From this water main, there's a service line that will specifically take water from the main utility line into the building. After the water passes the water meter line, the owner and the responsibility for the water changes. While the utility is responsible for water quality before the water meter, the school owner or the property owner is responsible for everything that happens beyond the water meter. Sorry, I don't know why that clicked ahead. Building water systems can have single or multiple buildings. You can have a single service line that will go to field houses, concession stands, and other buildings. And there might also be other sources for the water, like on-site wells. So what is stagnation? Stagnation, as defined by Merriam-Webster, is a state or condition marked by lack of flow or movement. So when water enters buildings that aren't using water, it will sit still. It won't be going anywhere. There will be no flow in all of those pipes. This happens regularly in most buildings. Overnight, for example, there's low or no water use, resulting in stagnation of several hours. Most office buildings and other commercial buildings will have periods when they're closed, like the weekend. There are taps in your home that you probably only use on occasion. Think about that basement bar that you never use unless there's company, or the guest bathroom. Stagnation can happen on a period of hours to even weeks in these specific locations. Outdoor spigots and irrigation systems might also have significant stagnation. While a lot of these stagnation periods are short, closer to a week, this can also last much longer. For example, summer breaks at schools will result in long-term stagnation. The off-season for sports facilities can result in long periods of no use. And there are many other situations that will result in this similar phenomenon. Now, stagnation can be problematic. When you have normal water use, you will refresh both the disinfectant residual and the corrosion control measures in all portions of the pipe. Disinfectant in water is used to reduce microbial growth. Typically, this is chlorine or chloramine in municipal water systems. There are also corrosion control measures that are used to reduce metals leaching from pipes. These can stabilize the pH and add chemicals. In normal water use, these constituents are brought to every portion of the water system periodically. Over time, they'll fade during those periods of normal stagnation, but the next time water is used, they're refreshed in the pipe again, and reactions like metals leaching from pipes and microbial growth are controlled. Now, if there's no water use for a period of time, these disinfectant residual and corrosion control measures will completely disappear. This results in microbial growth and uncontrolled corrosion. Now, because we don't exactly understand how these reactions occur on the long-term scale, we can only say that they're uncontrolled, but we suspect that it'll cause real problems that will pose significant health risks. So, as Mike mentioned, there are several health risks posed by stagnation. Copper can leach from copper pipes or from scale attached to the pipe, and these cause a variety of symptoms like nausea and abdominal cramps. Lead can also leach from lead pipes or brass pipes that have some amount of lead in them, or from scales where they've deposited over the years. This can cause more severe symptoms and include longer-term developmental issues for children. Scale can also be suspended, releasing other metals that have accumulated there. Now, these specific health risks are a concern for typically drinking water. Anytime we're exposed to water that we ingest or that, for example, animals are exposed to, these constituents are a major problem. Now, harmful organisms like Legionella pneumophila and other pathogens can also grow during the time of stagnation. Many of these organisms cause respiratory illness, like pneumonia, and other infections can also occur. Because of this, inhalation and dermal exposures are of a higher concern. For example, showering, flushing toilets, irrigation, or other activities can cause greater exposure to these microorganisms. Now, I do want to go into a bit more detail on these microorganisms. First, they're naturally present in both natural and engineered water systems. It's not uncommon that they would be found in the municipal system at low levels. These often cause respiratory infections like pneumonia. Exposure occurs through inhalation, aspiration, and dermal routes, including the eyes. So activities like showering, standing next to decorative fountains, flushing toilets, standing in steam rooms, or being exposed to sprinkler systems or slip and slides can be problematic. Immunocompromised persons are at higher risk for infection. This particularly includes the elderly and those with pre-existing conditions. And I've talked a lot about Legionella pneumophila, but there are also other organisms that cause similar disease. Non-tuberculous mycobacteria, Pseudomonas aeruginosa, and various amoeba, including Naegleria fowleri, the brain-eating amoeba, have been found to grow in stagnant water. Now, these organisms tend to grow in biofilms, but when water starts to flow, they can be suspended into the water phase and then be suspended into the air. Those who are showering can inhale them into their lungs, where they will cause a pneumonia infection, or they can be exposed dermally, for example, through a wound or the eyes or the ears. This is rather problematic, and one of the things we've seen with COVID-19 is that these symptoms will get overlooked and people will think that it's COVID and actually misdiagnose the disease. We also don't know if people who have COVID-19 might be more susceptible to these lung infections because they are already fighting another infection. Now, in order for water to not be stagnant, we need to refresh the water. And this, first and foremost, requires an understanding of the plumbing configuration in the building. Now, the goal is to get rid of all of this brown water inside the pipes and replace it with fresh water. Now, to do that, we might start by flushing a basement tap. This will bring fresh water in, and depending on how long we flush it, it'll bring fresh water all the way to that tap. However, there's still stagnant water in the rest of the system. Maybe we move to another floor and begin to flush that tap as well. But you can see there's still quite a lot of brown water in these pipes. Of course, the hot water system hasn't been touched at all because we've only been flushing cold water sinks. So if we begin to flush a hot water sink, we can begin to refresh this water. And as you can see, all of the taps will need to be considered. Another thing that's really important is to understand plumbing configuration and how these different pipe outlets are connected. What you can see when you walk through a building, and this is a typical office building, is the water appliances like water softeners and water heaters in the utility room. You can see toilets that use the water, bathroom sinks, kitchen sinks, utility sinks. You can see irrigation systems outside or showers. You can also see other appliances like the refrigerator or dishwashers or water coolers that are all connected to the drinking water system. Now, there are many different ways that these pipes could be connected. They could be connected on a simple central riser that distributes water to all of the use points. Hot water systems can be more complex, however. In order to save energy in large buildings, a lot of hot water systems have begun to use recirculating systems. In recirculating systems, there are pumps attached that will move hot water throughout the pipe systems of each floor or through risers in order to keep the water hot and fresh near the point of use. This reduces the amount of time that you actually need to achieve hot water temperatures at the point of use. Another option is that you have multiple risers in a building. Especially when there's been multiple additions or renovations, you can have a very complex water system. Now, in each of these different systems, there would be a different plan for flushing and a different amount of time needed to flush each individual tap. And of course, as I said before, refreshing the water in the system requires consideration of all taps. Just because you flush a few for an extended period of time doesn't mean that you're getting water to all of the points in the system that need refreshing. When considering all the taps, it's important to think about potential sources of exposure. For drinking water, you can get that drinking water at a kitchen tap, at ice dispensers. Bathrooms might be used for drinking water, even though they're not supposed to be. Plumbed water dispensers like water fountains or bubblers, or even water coolers can be used for drinking water. And really any faucet might be used for drinking water use. Domestic hot and cold water can be used for hand washing, bathing in showers, dishwashing, including using appliances or those sprayers in industrial kitchens, and toilet flushing. Certain buildings might have recreational water, like the pools, or have certain equipment that's hooked up to the water system. Devices like humidifiers and cleaning equipment could also be a point of exposure to aerosols for microbes or to other exposures. Irrigation systems, although they're outside, can still result in harmful exposures. Fire suppression systems are interesting in that they're always stagnant, but it's important to make sure that there's proper backflow prevention that's keeping that stagnant water away from your primary water systems. Heating, cooling water, like cooling towers, will have a similar design aspect. And of course, medical equipment might be hooked up to the drinking water, although typically we use a more sterile water for those systems. Now, the good news I know I gave a lot of bad news, is that there are strategies to mitigate water issues. There's a lot of information at plumbingsafety.org, and I'm available for questions. But at this point in time, I'll hand it over to Dr. Whelton, who will talk more about actions that can be taken in school systems.
All right. Well, thank you very much, Dr. Proctor. I am going to talk with you a little bit about getting your school buildings ready for use again, and then how to operate them under low water use conditions. A special thanks to the contributors to this effort. There's a lot of faculty, staff, and students at Purdue University that are doing a tremendous amount of work here, helping schools and building owners better understand their water systems by just advising them, helping create flushing plans, educational materials, or actually going on site and conducting the testing ourselves. So the learning objectives of this session are to really identify what types of plumbing components that you should be worried about, and Dr. Proctor touched upon a few of those. Describe how to determine if your school building contains stagnant water, and also explain the general process for flushing a building water system. We get a lot of questions about, should I test my water? What should I test it for? How frequently? And we're going to talk a little bit about that. And then finally, how to maintain your system under low occupancy or low water use conditions. As Dr. Proctor mentioned, building water systems are complex, and school properties can be complex. Once that water passes the water meter, it becomes the school's responsibility. You may have multiple different pipes going from the water meter to different buildings. You may have one pipe that branches off and feeds water to other buildings, and you may have field houses, concession stands, classroom buildings, administration buildings, maintenance buildings, and more. So school campuses can be complex, and there can be more than one building on the property that you should pay attention to. So describe your building water system. If you're trying to figure out a way to think about what do I do next? Well, think about where your water supply source is. Is it from a public water supplier, somebody that gets that water, treats it, and sends it to your property, or is it from an on-site well? Where it's actually being captured on the property. What's the physical location of that water enters the campus? How many buildings on campus use water? And then where does that water enter each building? You're basically going to be a detective and track where that water goes, because really the building water system pertains to the fate of that water and the safety of that water throughout the entire property. You want to ask yourself, where are the water heaters? How many do you have? Some schools have multiple water heaters because some of the water heaters are set at different temperatures. Not all water heaters are at the same temperature sometimes. How many recirculation loops do you have? And Dr. Proctor mentioned this. At one of the schools we went to, they had 4 different hot water recirculation loops, which was not unusual, but more than one water heater like maybe you're used to at your home. There may be multiple pressure zones. There's only so much water pressure that gets water to, say, a first floor level building. And if we were going to push that water up 5 floors, we may run out of pressure and water may never get there when we turn on the faucet. So sometimes there may be booster pumps, there may be other types of pressure devices and indoor water tanks to keep pressure in the system. So building water systems are complex, and this is important to consider. Now, one of the questions that we get asked a lot is, so how do I know if I have stagnant water? And has every water outlet been used, flushed repeatedly in each building? And the answer to that question, even for your homes, is no, because you go away, you return from work, from going out for activity, same concept happens at schools and other buildings. So you likely have stagnant water, but the question is, to what degree is it stagnant? And as Dr. Proctor mentioned, there's chlorine residual or disinfecting chemicals that are deliberately put into water to basically keep the microorganisms in the biofilm, keep them out of that bulk water so that they don't get delivered to you. And if we have stagnant water and allow that chemical disinfectant residual to disappear or go away, then the bugs are going to start coming out and playing, and then that's a problem. So you may have situations in some buildings we have very old pipes and corrosion that you can't get disinfectant residual deeper and maybe a weekend is just enough to get stagnant water, or it may be a much longer. It really depends on the building and different parts of the building. Safety is very important for building water system maintenance. As Dr. Proctor mentions, inhalation of aerosols that may contain Legionella and other organisms is a real risk. And it is generally assumed that Legionella can be present in stagnant building water systems, and workers should consider wearing fit-tested N95 respirators according to OSHA for flushing activities. These respirators are recommended for maintaining cooling towers where it's definitely possible that Legionella and other pathogens can be aerosolized and workers can inhale them. And the same concepts go for building water systems as well. Goggles, gloves, and other PPE is also remembered. And the longer the stagnation period, the greater potential Legionella concentrations or other issues can be present. And so if you have a water system that's been stagnant for 3 months, you're probably in a different situation than a water system that's been stagnant for maybe a week or so. So the best thing to do is keep the water moving, and we're going to talk about that here. So the first step in determining how you'll flush the building water system is contacting the water supplier. So maybe you've been conducting maintenance and your maintenance or other staff members have been opening certain faucets, but really, have you done a good flush yet? Have you really figured out how to flush that system well? Contact the water supplier, tell them what you're doing. What are they delivering to you? What chemical are they putting in the water? And what levels should you expect to find it at the water meter? Because that's going to tell you what you should be looking for. Step 2, bring fresh water to the building. Flush out the buried water pipe that moves the water from the meter to the buildings. And this is important because, again, this could be hundreds of feet or it could be thousands of feet. And the amount of water that's in that pipe is going to dictate how long you're going to have to flush the water in the building to get all that water out. Step 3, determine if you have fresh water coming to the building. So are you flushing and getting fresh water? Some places having a lot of stagnation in the utility water mains. And that's because many of the buildings in commercial districts and elsewhere are not using much water nowadays. So water is becoming stagnant in buried water mains, and what you don't want is to draw in that stagnant water into your building thinking that it's fresh water. So utilities will be very likely to help you through the process to determine if the water going to your property is fresh. And to do that, there's some very simple things you can do. I'll show you on the next slide here. There's 2 different kits that you can buy that can help you do very basic things for your building water system. And I did want to point out this picture here on the right. This is the faucet aerator. It screws on to this 2-handle faucet. And what you see there is black material, black debris that was flushed in from the building water system and basically impacted onto this aerator. So why that matters is all water that comes out of that faucet passes over that black material. And as I mentioned to you before, pathogens, biofilms, and microorganisms need real estate to live. And so they will live on this type of debris material. They may not live there in great numbers, but when the water goes stagnant, they may populate and become more significant. So the best thing to do while you're flushing is unscrew these aerators and clean them out. And if you need questions about, if you have any questions about how to do that, we can help you. It's pretty easy and it just involves vinegar. So disinfectant is something that we want to look for in buildings. The happy face is the pink solution and the sad face is the clear solution. Both of those vials had this chemical powder put into it, very inexpensive. And what happens is you put it in the powder in the water, you shake it up, you leave it for a few minutes, and then you put it into an instrument there on the left, and it detects color and tells you how much chlorine, for example, here you have in the water. So this is pretty easy to do. Water treatment plant operators, resorts, all sorts of different people from different expertise areas use these kits, very easy to use. There's also a digital thermometer. That's also something that every school should have because this can help the maintenance and facilities folks understand, is the hot water hot enough? Or if there's issues with hot water consistency, as well as have you flushed long enough? Have you got all the hot water out of the system and now it's replaced with cold water? So step 4, 5, and 6, and this will take us to the end here, is to remove and clean the aerator faucets and then go to the point of entry and flush cold water throughout the entire building. So you're gonna go march from the point of entry of where the water enters the building all the way through the building, as Dr. Proctor showed, and get all that stagnant water out. You're gonna include toilets, urinals, faucets, water fountains, showers, and outdoor spigots. So drinking water that's typically delivered to buildings is used often for toilet flushing and urinals. And so you don't want to forget those devices because they can, if gone stagnant, pose health risks as well in terms of aerosolization of pathogens. Just want to flush everything out. Plus, toilets and urinals can flush a lot of water compared to, say, an electronic faucet. And that helps you move water through the building faster. Step 5, go back to the point of entry. And now focus on hot water. And so first, start with the water heaters. These are generally large tanks, sometimes 300, 400 gallon tanks, and the hot water circulation loops that go out into different parts of the building. And you want to clean those out first. The reason why you do want to do that for hot water is because if you were to go to a faucet and start flushing hot water, you would basically be drawing the water from the water heaters and the hot water recirculation loops. You don't want to do that. You want to save yourself time. You want to drain those heaters, fill them up again, flush them out good. And if you shut off the heaters and loops, you can use temperature to monitor flushing. So that's helpful. Step 6, don't forget appliances. Don't forget the refrigerators, which have ice makers that are directly connected to the building water system. You'll see the plastic or copper lines that leave the ice maker and go into the wall. Those are generally water lines. Dishwashers, coffee makers, point of use devices like filters on faucets or under sink filters, as well as water softeners. Out here in Indiana, a lot of schools have water softeners. We want to make sure that those are maintenance, those are flushed according to the manufacturer's instructions. And you may need specialized expertise. So if you have cooling towers or a cooling tower, you definitely probably need to contact somebody who's an expert on cooling tower safety. Water heater tanks, fountains, recirculation loops, and all sorts of other things you need to focus on. Now, above all, keep a log. Write down everything you're doing and document it, because this will be the basis of a plan that you may have heard about called a water management plan. Now, going to the testing considerations questions. Should you test? And my answer for everybody is yeah, you should. You should be testing disinfectant residual and water temperature. These are inexpensive, easy to do tests, and it kind of gives you a gauge upon what's happening to the water in your building. And so this can be done in the morning, in the afternoon, on the evening, before people go home from work. It's very effective in helping understand if fresh water is coming into the building and if fresh water is entering different locations. Should you do other samples? Well, it depends on your population. And so if you're going to have, for example, children drinking water out of water fountains, and you want to know that the water is safe in terms of copper and lead. If you have half occupancy or a third occupancy of your building, you would expect that those water fountains would be used less. And so therefore, maybe you might want to consider copper and lead testing. But you want to also consider cafeteria faucets. So even if you've disabled the fountains, where food preparation is happening, or break room faucets. And then Legionella and other microorganisms are potential considerations. Here, though, you really need to think about the risk factors, and I would talk to an expert about this. it generally is not a good idea to go sample for something and not really have any idea about what you're going to do with that information when you find it. So find and talk to somebody now about what to do so that collectively you can move together. And once the building water system is prepared, keep the water fresh. So low occupancy, low water use may mean a greater chance for stagnant water. And you don't want to go back to where you started necessarily, where there was no water use and you had stagnation. You've already heard reports where individuals have flushed in 3 months stagnant water and seen black water come out. Black water is not a good sign in a stagnant plumbing system. And so you don't really want to get there. You want to keep the water fresh. Make certain the water heating systems are set at the correct temperature. You can test water for disinfectant, residual, and temperature. And if you have any concerns or you think there's any red flags there, call somebody, ask for help. Keep flushing water through the building at underutilized areas and make sure that you keep a log and write everything down, because it's going to help when you ask for help and advice. So with that, I want to thank you very much for the opportunity to talk with you today. More information can be found at Purdue's website, plumbingsafety.org. And if you have any questions, please don't hesitate to contact us. I'll give you back to Mike. Thank you.
Appreciate the information, Dr. Whelton and Dr. Proctor. On the surface, this can be a bit nerve-wracking to think about how dangerous our water can become just by sitting in the pipes. And there are complexities, as you've explained, in these water systems. But these suggestions and tools you've recommended are a great start in managing these hazards associated with drinking water. We can talk about flushing, and we can talk about checking our temps and our disinfectant residuals on a regular basis. And if we do that routinely, we can really prevent ourselves some significant costs later on. Again, appreciate your efforts in helping prepare for this upcoming school year as the school buildings begin to open up. I want to thank you all for watching the webinar, whoever has been able to join in today and watch this webinar. We hope this is a helpful tool for you to use in managing your water systems. The Indiana State Department of Health has placed building startup guidance on our website for your convenience. The link is listed on the slide here, as well as a web address where the guidance is located. I also wanted to mention a Q&A session that we're going to be hosting. That'll be Dr. Whelton, Dr. Proctor, and myself on July 23rd at 10 a.m. So we'll spend an hour or so answering any of the questions that you might have after watching this webinar, or just in general that you might have regarding your premise plumbing and the management of your water systems. This is going to be a live interactive event. So we will be able to answer questions on the fly. You don't have to submit anything ahead of time. There will be a link to the Q&A session located on the ISDH website, as well as in the same location as the guidance. So we look forward to seeing and hearing from you during that Q&A session. We're also going to place a PDF version of the slide deck that was used in today's webinar for your access at that same web address, where these other resources are going to be located as well. So utilize that web address, www.in.gov/ISDH/20408.htm, and you can find these resources. Again, thank you so much for watching the webinar today. We hope it has been helpful for you, and just know that Dr. Whelton, Dr. Proctor, and myself are here to help support you in maintaining those water systems. Thank you very much.